All right, and so in this video, we're going to go over some of the odd problems from the Solving Polynomials assignment. Remember, this is not meant to be a lecture video, but just a quick recap on how to do some of these problems and kind of an answer key. So the biggest exponent in this problem is 3, which remember means we will have 3 roots or 3 solutions. You should probably start this problem by going to your calculator, going to y equals, typing that in, and graphing it. Here you can see one of your answers is x equals 4. And if you can't tell it from the graph, you can hit second graph and see the table that x equals 4 is indeed one of our solutions. So I'm going to write one of my solutions right here. Now from there you can find the other 2 solutions a couple of different ways. Both involve division. So if you're a fan of long division, you're going to divide the original problem by x minus 4. If you're a fan of synthetic division, which is what I'm going to use here, you're going to set up your synthetic division problem, where 4 goes in the box there because it is a solution. And our coefficients go across the top: 1, -4, -6, +24. And we go through the process the other video taught where we add. We're going to bring down that first number because it's not being added to anything. And then we're going to multiply that number by 4. And we get 4. Then we're going to add, we get 0. And then we're going to multiply that number by 4. Add, multiply. That's a good sign that we got 0 at the end, so there's no remainder for this problem. So remember, these numbers are the coefficients for the answer. We started this problem as an x to the 3rd problem, so that means when we divide, our answer should be taken down a degree. So we get 1x squared. There's no x term, plus 0x, I'm not going to write that, minus 6. So that's our other factor, and this is where we're going to find our other 2 solutions. So that's a degree 2, so there should be 2 solutions from this. At this point, you can solve this using quadratic formula. A would be 1, B would be 0, C would be -6. Or the faster way would be add 6 to both sides. So you get x squared equals 6. Take the square root of both sides. Or when you take the square root of both sides, you get a positive and negative answer. So your other 2 roots or other 2 solutions are positive radical 6 and negative radical 6. I'm going to write it out as 2 different numbers, but you absolutely could write plus or minus radical 6. All right, so the next example is, again, the highest power is 3, so that means we're going to have 3 roots. We're going to start by putting this problem into the graphing calculator, which I've done there. We're going to graph it. And again, if you can't tell what the roots are, you can examine the table of values. If you hit second graph, and we hit second graph, we actually have multiple roots. And you can kind of see this from the graph, but this one crosses at -2. And it crosses again at +2. There's multiple ways to go from here, but I'm going to keep it simple and use the same process. I'm going to use synthetic division and first divide this original problem by -2. Or again, if you use long division, you could divide by x plus 2. Whatever method makes more sense to you. Write out my coefficients, 5, -1, -20, and 4. And these are just the coefficients from the original problem. And then we're simply just going to add and multiply. So 5 plus 0 is 5, multiplied by -2 is -10. Add those together, you get -11. Multiply that number by -2, and you get +22. Add those together, you get 2. Multiply, you get -4, and no remainder. So the coefficients of our answer are 5x squared minus 11x plus 2. You could do quadratic formula. We already have one of the solutions we know we're going to get from quadratic formula. We just need to find the other. Or what we can do is now we can divide this using synthetic division one more time. And we can use x equals +2. We're just going to take this down one more degree. So 5 plus nothing is 5. Multiplied by 2 is 10. Add, multiply, no remainder. Why this makes it a lot easier is because now our answer is 5x. We've taken it down one more degree from a quadratic to a linear. And now we've got a linear equation, which is super simple to solve. Add 1 to both sides and divide both sides by 5. So we're going to get 1/5, or you can write that as a decimal, 0.2. Again, there are a lot of different ways to do this problem. This is just one way to do it. All right, and this final problem is degree 4. The highest exponent is 4, so that means we're going to have 4 solutions. It's not really any harder than the other problems, just longer. So same thing, I typed it into the calculator right here into my y equals. I'm going to graph it, and we're going to see exactly where it crosses. Looks like it's only crossing 2 times, which means 2 of the solutions are going to be real and 2 of the solutions are imaginary. Unless I just need to zoom out and see the others, my guess is that's not the problem. So when I look at the graph, it looks like it's crossing at 3 and 4. I can verify that by doing second graph and looking at the table. And then, yep, there it goes. At 3 and at 4, it's crossing. So I'm going to go and draw an answer box and write 2 of the 4 solutions. It's that easy to find half your answers. Use that calculator. The other 2 are probably going to have to be solved using quadratic formula. But we can't do quadratic formula until it is a degree 2 problem. So I'm going to divide this original problem using synthetic division. We should not get a remainder here if we've done it right. So we're going to add and multiply. Bring down the 3, multiply it by the 3 in the box. You get 9. Add, you get -12. Multiply by 3, you get -36. Multiply 2 times 3, you get 6. You get -8. Multiply by 3, we're just adding and multiplying. So now we've taken this down a degree. We've taken it down to 3x to the 3rd minus 12x squared plus 2x minus 8. Still can't do quadratic formula until it's a quadratic, so we're going to divide one more time. This time we're going to put the other solution that we found in the box. We're going to put 4 in the box. And then my coefficients go across the top, no placeholders, so it makes it simple. We're going to add and multiply. So I end up with 3x squared plus 0x, which we don't really need to write, plus 2 equals 0. Could solve using the square root method, or you can do quadratic formula. Quadratic formula would be b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Simplify the discriminant here. And I believe that's negative 24 plus or minus the square root of negative 24 over 6. We're going to simplify square root of negative 24 using a factor tree. Go through this part pretty quickly since it's old material. So there's my other 2 answers. And remember, that does count as 2 answers because it's positive and a negative answer. So we don't have to write it out twice. We use those symbols to save us a little bit of time. So I'm going to go back to my answer box and write plus or minus I square root of 6 over 3. I think that's right. Make sure. Yeah.